transfer function, it is defined as the ratio of Laplace transform of the output to the Laplace transform of input with all initial conditions are zero. That is the assumption we are making. So while taking the Laplace transform, we are going to assume that all the initial conditions are 0. That is defined as the transfer function. Transfer function is also defined in another way. So it is defined as Laplace transform of impulse response of the system, with all initial conditions are 0. Here also we can define this transfer function in two ways, that is Laplace transform of the output to the Laplace transform of the input with all initial conditions are 0, or it is defined as the Laplace transform of the impulse response of the system. So first of all, you have to take the impulse response of the system. For that, if you take the Laplace transform, then also you are going to get the transfer function of the system. But very popular definition was this one, and this definition is going to ask for competition exams. So both definitions are very important for the competition exams, right? So if you write mathematically the first definition, so what is the transfer function? We can define the transfer function. First we will define in the time domain. When you take the transfer function in the time domain, let us consider the system is z of t. So c of t is the output divided by r of t. So when you give the transfer function, when I am drawing in the time domain, if you observe in the time domain, the transfer function will be like this. The system, you are giving the system here, then the output will be c of t and the input will be here is r of t. For this the system is given. So if you are converting into Laplace transform, the system can be written as, so for the system we are converting into s domain. So what is the time domain can be, that is z of s. So that is will be taken as, here is r of s and the output we are expecting is c of s. So here you can convert into Laplace transform. Whenever you are converted into Laplace transform, then you can write as c of s divided by r of s, that is equals to z of s. This is the mathematical expression we can write the transfer function. So another definition, so you have to take the impulse response. Let us take the impulse response of the system. So we are taking the impulse response of the system, here is g of t, small g of t. So what the transfer function, another definition will states that transfer function also will be defined as, that is equals to Laplace transform of this impulse response. We can say it as the transfer function. So what is the condition you have to remember? So the condition to be remembered is with all initial conditions are 0, with all initial conditions are 0 for any definition you consider the transfer function. So that is the basic definition of the transfer function. Next we will see what are the types of the transfer function. So there are two types of the transfer function will be there depending upon the order of numerator and denominator of the transfer function. Let us take one example in the previous slide only. So I will take one example, C of s divided by R of s as here is equals to s plus 4 divided by s square plus 2s plus 5. So this is one example I have taken for the transfer function. See here, if you come, what are the types of the transfer function? So transfer function will be depending upon the order of the numerator and denominator. Based upon that, so by comparison of order of numerator and denominator, we can take the types of the transfer function. So now we are going to compare the order of numerator and denominator of the transfer function. Based upon that, the transfer function is divided into two types. One is called as proper transfer function. So what is the meaning of the proper transfer function? So here I will write, so if n is greater than m, then the transfer function is called as proper transfer function. I will tell what is the meaning of the n and m. Second one is improper transfer function. So improper transfer function means that whenever you have improper transfer function, so if m is greater than n, the transfer function is improper, we can say. What is here? N and m are defined as, so n is the order of the denominator of transfer function, m is the order of numerator. So these are the order, means you know already. So as we taken previous example, so here C of s divided by R of s, if you write here, it will be s plus 4 divided by, I have taken s square plus 2s plus 5. Here the order will be, if you observe, the order of the denominator is 2, that is highest power. The order of numerator is 1. That means we can say here n is greater than m, where n is 2 in this case here. That means the denominator order and m is the numerator order, so that will be greater. So this is called as the proper transfer function. Whenever you take another example, let us take another example here, C of s divided by R of s. Just I am taking reverse of this, s square plus 2s plus 5 divided by s plus 4. Here you observe the highest power in the denominator is 1, highest power in the numerator is 2. So what we can say, here the case will be m is greater than n. So that means here m will be 2, here it is greater than 1. This is called as the improper transfer function. These are the two types of the transfer functions are there in the control system, proper transfer function and improper transfer function. Let us see what are the advantages and disadvantages of the transfer function. So let us take what are the advantages of the transfer function. If you observe the advantages of the transfer function, first it is going to see, first one is, so it gives the mathematical model. Okay, so it gives the mathematical model of system, components individual analysis can be made by using transfer function. Individual analysis can be made by using transfer function. So, from this mathematical model of all the system components, you are going to get individual analysis can be done by using the transfer function. Second important point is it helps to determine important information systems such as pole and zeros, We will see what is the meaning of the pole and zeros in the root locus diagrams. So, what is the meaning of the pole and what is the meaning of the zero, we will see in the root locus problems. Stability analysis can be easily done here. Stability analysis can be done by using this transfer function. Another important point, fourth one, easy to convert. So, it is easy to convert time domain into S domain. So, if you take the time domain, you can convert very easily the transfer function into S domain and also vice versa. So, this will be happened in vice versa also. You can take by taking the, whenever you are converting this time domain into S domain, you have to take the Laplace transform. Whenever you are converting S domain into time domain, you have to take the inverse Laplace transform. So, by doing these mathematical tools, we can convert time domain into S domain and S domain into time domain. Let us see the disadvantages of the transfer function. So, first disadvantages, if you observe here, what is the disadvantages of the transfer function? First one is it is applicable only for linear time invariant system, applicable to linear time invariant systems. So, that is the major drawback, we can say linear time invariant systems only it is applicable. It does not provide any information. So, it does not provide any information about physical structure of the system, physical structure of system. Another important point is third one, initial conditions are having zero, initial conditions lose their importance. That is the another disadvantage of the transfer function. So, this is that's all in this video. So, these are the advantages and disadvantages of the transfer function, and you can say types of transfer function also and definition of the transfer function. That's all in this video. If you like this video, please like, share and subscribe the channel. If you have any query, please make a comment in the comment box. I can reply. Thank you very much.